Need to expose custom tools to AI assistants without building a full API. We'll create a simple FastMCP server that lets AI models roll virtual dice, showing how to define callable tools with type hints and docstrings. You'll see the exact pattern for registering tools and running the server in just a few lines of code.
Import random. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dice roller. At MCP, tool. Def roll dice, n dice, int list int. Roll n dice, 6-sided dice and return the results. Return random, randint 16 for in range n dice. If name equals main. MCP, run.
This demonstrates the tool exposure pattern for AI-augmented applications. The decorator-based approach transforms ordinary Python functions into AI-callable tools, creating a clean boundary between your business logic and the AI integration layer. What makes this distinctive is how it preserves native Python semantics while making functions discoverable and executable by external systems. The pattern works by using decorators as declarative markers rather than imperative instructions. Your function remains pure implementation logic, while the framework handles registration, type introspection, and transport concerns automatically. This separation enables true modularity. You can develop tools as standalone Python components, then expose them to AI systems without modifying the core logic. This approach solves the common problem of AI integration complexity by eliminating manual API scaffolding. It's particularly valuable when building extensible systems where you want to expose capabilities to AI agents without coupling your code to specific transport protocols. The trade-off is framework dependency, but the benefit is dramatically reduced boilerplate and faster iteration on AI-augmented features. Let's break it down line by line.
Import random.
This imports Python's built-in random module, which provides pseudorandom number generation. The roll dice function uses it to simulate dice rolls with random, randint 16.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI-callable tools. It transforms Python functions into structured tools that AI models can invoke, complete with type hints and docstrings as the interface schema.
MCP equals FastMCP. Name equals dice roller.
This instantiates the FastMCP server with the name dice roller. The name identifies this toolset in the AI's available functions, enabling clear routing and debugging.
At MCP, tool. Def roll dice, n dice, int list int. Roll n dice, 6-sided dice and return the results.
This decorator exposes roll dice as an AI-callable tool through FastMCP. The type hints and docstring automatically generate the tool's schema, including parameter validation and return type enforcement.
Return random, randint 16 for in range n dice.
This is a list comprehension that generates n dice random integers between 1 and 6, simulating dice rolls. The underscore discards the loop variable since we only care about the count, not the index. This pattern efficiently creates the result list in a single readable line.
If name equals main.
This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Without it, importing this file would accidentally start the FastMCP server.
MCP, run.
This starts the FastMCP server, exposing all decorated tools to connected AI models. Without this call, the tools exist but remain inaccessible. Standard entry point pattern for FastMCP applications. FastMCP tool decorator pattern. The MCP tool decorator transforms ordinary Python functions into AI-callable endpoints, automatically generating schemas that bridge human code and model capabilities. Your tool's docstring becomes its public interface, so write it for both machines and humans. This single decorator handles registration, validation, and transport, letting you focus on logic rather than plumbing.
The decorator that names the tool becomes nameless in the call.